Welcome everybody to our second example of Taylor series expansions of functions. So what we're asked to do in this example is to find the fifth degree Taylor polynomial for sine of x evaluated or centered around x is equal to pi. And so for a fifth degree Taylor polynomial, we need 5 derivatives. So for our first function, for f of x, we just have sine of x. For f prime of x, derivative of sine gives us cosine. For our second derivative, we have a minus sine. For our third derivative, we have a minus cosine of x, so minus cosine of x. For our fourth derivative, now we're back around to sine, and for our fifth derivative of x, we have cosine again. And so now if we take each one of those and evaluate at pi, what we find is the sine of pi gives us 0. Cosine of pi for our first derivative gives us minus 1. Our second derivative evaluated at pi gives us 0. Our third derivative evaluated at pi gives us 1. Our fourth derivative evaluated at pi gives us 0, and our fifth derivative evaluated at pi will again give us minus 1. And so with all of these values, now we're kind of able to write out what we have for the polynomial itself. And so for our fifth degree Taylor polynomial, we have f of pi plus f prime at pi over 1 factorial x minus pi plus f double prime at pi over 2 factorial x minus pi squared plus our third derivative at pi over 3 factorial x minus pi cubed plus our fourth derivative evaluated at pi over 4 factorial x minus 4 or x minus pi to the fourth. And then finally, our fifth derivative evaluated at pi over 5 factorial x minus pi to the fifth. And so if we plug in the values that we have now that we just calculated on the last screen, what we have is a minus 1 over 1 factorial x minus pi, and then we had a plus 1 over 3 factorial x minus pi cubed, and then a minus 1 over 5 factorial x minus pi to the fifth. And so we end up with a final answer that looks like a minus x minus pi plus a 1/6 x minus pi cubed, and then finally a minus 1 over 120 x minus pi to the fifth. And so this gives us our fifth degree Taylor polynomial for sine evaluated at or centered at pi. Of which, if we now kind of compare the graph of sine that we see here in green. So our graph of sines here in green, the graph of our fifth degree polynomial is here in red. And we can see that centered around pi, we have an exact fit. And actually, we have a pretty good fit for sine up past pi over 2 and up past 3 pi over 2. We get a pretty good fit up to those values. And so our polynomial overall is going to be a pretty good fit whenever we are close and kind of a good distance away from our value at pi. So I hope this has been useful, and I will see you guys in the next video.